In this video, we're going to look at some special angle relationships. The first one I'm going to show you is called adjacent angles. And this word adjacent means next to. So we're going to look for some angles that are next to each other, which means they're going to share a common side. So let's draw an acute angle here. I'm going to call this A, B, C. And I'm going to split this angle into another angle, and I'm going to call this point D right there on that angle. So if I look at this, I now have two angles that are next to each other. I have angle A, B, D, which is this right here. It is next to angle D, B, C, which is this angle right here. And they share a common side of ray BD, and then they also share a common vertex of vertex B. So let's look at another example. Let me erase this first. And this time we're going to look at an obtuse angle. And I think I will call this CAT, and my other angle I'm going to put a point B on it. So I have just formed two angles that share a common side. My first angle is this one right here, CAB, so this red angle right here. And the one that is next to that is going to be angle BAT, this small acute angle right here. They share a common side of ray AB, and they share a common vertex of A. So they are called adjacent angles. So now we're going to see if we can identify some adjacent angles. So I'm just going to pick any angle to start with. Let's do angle HGB, so this angle right here. If I'm looking for something that is adjacent to it, I'm looking for something that shares a common side. So there's actually two options because there's one on either side of this angle. I'm going to say angle HGB is adjacent to BGC, this angle. Those two angles, the red and blue ones, are adjacent. The red one also is adjacent. I'm going to color this one blue as well. The red one is also adjacent to HGA right here. So this red angle is adjacent to both of those. Let's look for another relationship here. I'm going to just pick another one. Let's pick AGF, this angle right here. Again, we can look at either side of it in this example. So I'm going to say it is adjacent to FGE right here. It is also adjacent to AGH over here. So when we're talking about adjacent angles, we're talking about angles that simply share a common side, and then they'll also share a common vertex. The next angle relationship I'm going to talk about is called complementary angles. Complementary angles have a sum of 90 degrees. So you'll notice that I've drawn two angles here, and these angles right now don't happen to be adjacent. But I can move them around, I can make them larger, I can make them smaller, I can rotate them in any way that I want. It doesn't make any difference, they're still the same size. But what I'm looking for is, when I combine them, do they have a sum of 90 degrees? So what I'm going to do is I'm going to make these angles share a common side and share a common vertex, so we can see if they add up to, or if they combine to form a right angle. And I didn't draw these perfectly, but you can tell that these two angles, when we combine their angle sum now, when we find their angle sum, we now have a right angle. So these two angles are said to be complementary angles. The next angle relationship I'm going to show you is called supplementary angles. And supplementary angles have a sum of 180 degrees. So you'll notice I've drawn two new angles here. These angles I can zoom in on, I can zoom out on, I can rotate them around to whatever orientation I want. I'm not changing the measure of the angles when I do that. But what I'm looking for here is when I put them adjacent to each other so that they share a common side and a common vertex, do they combine to equal a straight angle? Again, I didn't draw these perfectly, but you can see when I put them adjacent to each other that they combine to form this large 180-degree straight angle, so they're said to be supplementary angles. The last angle relationship that we're going to talk about in this video is called vertical or opposite angles. Vertical and opposite angles are synonyms for each other, so they mean the same thing. So when we're talking about vertical or opposite angles, we're going to have to draw two intersecting lines. And we have now 4 different angles that we have created. So I'm going to make this one a red angle. I'll make this one blue. This one here green, and my last one over here I'm going to make yellow. Vertical angles are angles that share a common vertex, but they do not share a common side. Now obviously we only have one vertex here, so we're now looking for angles that share that vertex but do not share a common side. So an example of vertical angles would be this yellow angle right here and this blue angle right here. You'll notice that this blue angle sides are right here, and the yellow angle sides are right here. They are not sharing any of those sides. Another vertical or opposite angle is this red angle and this green angle right here. Again, the green angle sides are over here, and the red angle sides are over here. They are not sharing either one of those. So let's try to identify some vertical or opposite angles. First thing I'm looking for is angles that are formed by intersecting lines. So I'm going to find some lines. Here's line CF. And line CF intersects with a couple of lines, but let's look at line HE here that it intersects with. So we found angles now. We found 2 intersecting lines. Now let's look at the angles that are formed by these 2 intersecting lines, and they're all going to share this common vertex of G, but what I'm looking for is angles that do not share a common side. They will be our vertical or opposite angles. So it looks like this one, I'm going to color this one green. This is angle HGC. It is opposite or vertical to angle FGE. Similarly, this angle right here, HGF, is opposite or vertical to angle CGE. Let's look at one more example on here. Let me erase this now. So let's find some more intersecting lines. How about line AD intersects with line CF? And we have again a common vertex of G. So our vertical angles will be these ones that do not share a common side. So angle CGD and angle AGF. And this one, angle AGC, is vertical or opposite to angle FGD. So let's now use what we know about angle relationships to find some missing angles. I'm going to start in the top left, and the first thing I notice looking at that is that I see 2 angles that combine to form a right angle. So they are said to be complementary angles. I know that complementary angles have a sum of 90 degrees. So I know the blue angle plus my 25-degree angle, which is the red angle, equals 90 degrees. Now I can solve that by simply taking my 90-degree angle, subtracting my red 25-degree angle, and I will get my blue angle that is the missing angle. Do a little bit of regrouping here, and I get a missing angle of 65 degrees. So let's now look at the bottom left angle relationship. I see 2 angles that appear to be supplementary, and they're supplementary because if I look at their combined angle sum. That forms a 180 degree straight angle. So if I know that they are supplementary, they have a sum of 180 degrees. So I can take the yellow angle that I know, add it to the green angle that I do not know, and I should get 180 degrees. Just like before, I can solve this by taking 180 degrees, subtracting the angle I know, 140 degrees, and I'm left with my missing angle of 40 degrees. So let's look at our last angle relationships on the right side, formed by these two intersecting lines. So I have a given that the red angle is equal to 80 degrees. First thing I notice is that the red angle is adjacent to the blue angle. The red angle is also adjacent to the yellow angle, angle D. In addition to that, the red angle and the blue angle, if I look at this, my given angle, the red angle, and then the blue angle, they form a 180 degree straight angle. So they are said to be supplementary. I know that supplementary angles combine to equal 180 degrees. So I can take 180, get rid of the red angle, and I have the measure of angle B. I can do exactly the same relationship between angle B and angle C. Angle B and angle C also combine to equal this big 180 degree straight angle. So if I use that supplementary relationship, I can take 180 degrees, subtract angle B, which I now know to be 100, and I find out the measure of angle C, which is 80 degrees. And lastly, one more time, I can follow that same pattern. Angle C and angle D are supplementary. They form a 180 degree straight angle. So knowing that, I can take 180 degrees, get rid of angle C, which I know to be 80 degrees, and I'm left with angle D, which is 100 degrees. You will notice that my vertical or opposite angles, so this angle right here, let's color these the same. This angle right here, this red angle right here, and my green one down here that I'm now going to color red. These two angles right here are vertical angles or opposite angles, and they both have the same angle measure, which is 80 degrees. They are congruent. The same thing applies over here, angle D, which I'm now going to color blue. Angle D has a measure of 100 degrees, and angle B, which I'm now also going to totally color over in blue, it also has a measure of 100 degrees. Vertical angles or opposite angles are always congruent. One last thing to notice in this angle relationship is if I combine all four of these angles, I form a circle, and a circle has 360 degrees in it. So my four angles should combine, A plus B plus C plus D, should combine to equal 360 degrees. So my given angle, we'll call it A, was 80 degrees. Angle B, which was this one right here, is equal to 100. Angle C was 80. And angle D over here was 100. If I add all those up, we have 200 and 160. 200 and 160, which equals the full circle, 360 degrees.